So, hi guys. So, we will start a new unit for this week. It's probability. And just same as last time, if you have like any questions, just like contact us or leave it for next class. And let's get started. Liz, do you want to start this off?
Okay. So what is probability? Probability is a numerical description of how likely an event is to occur. The probability of an event is a number between 0 and 1. So it never get less than 0 and it never get greater than 1. It's either a decimal or a fraction and stuff like that. P of x represents the likeliness of this event happening or the probability of this event happening. So there are typically three types of events: certain, possible, and impossible events. Speaking of probability, events can be roughly categorized into three types. So certain events, this event must happen. So this event, P of x, is equal to 1. Example is we are alive. That's certainly happening. And a second category would be possible events. These events can either happen or not happen. The events P of x is between 0 and 1, as said before. Example that there's 80% of chance that tomorrow will rain, or it could be 40%. Any number between 0 and 1 will work. And the third category is impossible events. This event cannot happen. So the P of x will be 0, which an example would be the sun will rise from the west. And special case is when P of x equals to 1/2, which means there's an equal chance that this does or does not happen. This is called an even chance. And to the right is a number line, I would say, that shows you the different type of categories that you can see.
Law of large numbers. So this is a very important concept of probability. And imagine that you have a coin. When you toss the coin, there's an even chance that it'll either land on heads or tails. However, this does not mean that you'll continue to get heads, tails in that pattern. If you throw in heads, you're not guaranteed to get tails on the second try. What this means is that when you have larger numbers amount of trials, the probability of you getting a heads or a tails slowly gets closer to 1.5, which is 0.5. However, this is just an accurate representation of how the probability is that you get a head or a tail, not your actual chances of getting a head or a tail on a coin. For example, here's an example of the large number, the law of large number. As you can see from the chart, we use different trials. The first trial, we get a head. Second trial, we get another head. So this shows you that you're not guaranteed to have alternating values. And we could see from this trend that the first two trials, we can have a frequency from 1 to 0.5 because you can either get 2 heads, 2 tails, or just a head and a tail. However, as you can see, when we get to larger number of trials like trial 9 and trial 10, the frequency slowly begins to approach 0.55 and 0.5, which is closer than our approximated value 1/2.
Cool. And yeah, here is kind of like a function that you can like formula, I mean, you can like write it down and to remember it. So, Ethan, do you wanna like kind of read it?
Okay. In its most basic form of probability of an event happens is like the number of ways that the event could happen is divided by the total of the event possible.
Yeah. Just leave it for a second to like you guys write it. So
Um,
go ahead.
Yeah, I'll go. For their forms, the probability can be expressed in three different forms. One's percentage, one's fraction, and the other one's decimals. All this form can be used interchangeably. For example, 75%, that also means 3 over 4, which is also like 0.75. The event have 75 chance to happen. So percentage is kind of like times 100% over the decimal, like time. Yeah.
Yeah, cool. So yeah, here is kind of like the famous probably question is dice. So William, do you want to introduce that?
Yeah, sure. So a six-sided die is basically a cube with a number on each side. That's either 1, 2, 3, 4, 5, or 6. And fair six-sided die, there's an equal probability, so there's an equal chance that you will roll either 1, 2, 3, 4, 5, or 6. So the question here would be, what is the probability to roll an odd number? So there are 3 odd numbers and 3 even numbers out of the total 6 numbers. So therefore, there's 3 ways that you can roll an odd number. So in the fraction from earlier, the top number would be 3. And in the bottom, there's 6 total possible outcomes: 1, 2, 3, 4, 5, or 6. So the probability of rolling an odd number when rolling a six-sided die would be 3 over 6, or here's 1/2.
Yeah. So here are some practice questions about that probability. So we can try the first one together. So Liz, do you wanna?
Oh, sorry.
Yeah.
So the first one says that Austin wrote 2 fair six-sided dice. Given that at least one of the dice shows a 5, find the probability that the other dice shows a 2. So it's asking, okay, this is kind of like a harder problem because it's asking for 2 numbers. And since it's want both number to be a number that they want, we'll use multiplication here. So just let me try to write that. So the first number they want is 1. Wait, no, sorry. Okay, so the first number that they want is a 5. And the second number they want is a 2. So just as we said before, in a six-sided fair six-sided dice, there is 1, 2, 3, 4, 5, and 6. So if you want a 5, the chance will be 1 out of 6. And if you want a 2, the chance will also be 1 out of 6. So to multiply these two together, you will get 1 out of 36, which is the probability that the first number that Austin wrote will be 5 and the second number will be 2. This is like a harder problem. We're gonna go over into these like later, but you guys can see how it works.
I want to add something. I think the most important thing to take away from this is that 2 separate probabilities, they don't affect each other. So when you roll 2 dice, the probabilities of rolling each are completely separate. So say you roll the first dice as a 5, the second one doesn't have a higher chance to roll a number other than 5.
Yeah, cool. So let's try the second one by ourselves, and after maybe like 1 minute, we can check answer together. Okay, so let's check answer together. Alex, do you wanna go?
Sure, I can go over this problem. Okay, let's look at the first subproblem in this problem. After a die is thrown, find the probability of getting a prime number. Well, let's just list out all the possible values that we can get. 1, 2, 3, 4, 5, and 6. Now, we can just extract all the prime numbers from here. And keep in mind that a prime number is any number with only two divisors, it and it 1. So that would be 2, 3, and 5. Now, since we have 3 prime numbers in here, we could divide that over 6, which is the total number of possibilities or outcomes that we can have. And that equates to 1 over 2. So we have a 50% chance of rolling a prime number whenever we throw a dice. Now let's look at the second question. A number greater than 4. Well, we can just count. We know that all the numbers before 4 and 4 in itself have to be excluded. So that only leaves 5 and 6. So that gives us 2 possible outcomes that would satisfy this constraint. So we would put that over the 6 possible outcomes and get 1 over 3. This gives us a 1 in 3 chance of rolling a number that's greater than 4. Now, for the final problem, it says to roll a number that is not greater than 4. Well, we can see here that all the numbers past 4 and 4 itself do not qualify this constraint. So the only possible outcomes that satisfy number 3 is 1, 2, 3. So that gives us 3 possible outcomes over 6 possible total outcomes, which again gives us 1 over 2. So we have a 50% chance of rolling a number that's not greater than 3. I'll just write it out again for you. 1 over 2, 1 over 3, and 1 over 2.
Yeah. So I will. Oh, okay. Never mind. Yeah. So here is the second type famous probability problems is coins. And yeah. Ethan, do you wanna go?
I don't really know how to do probability. I forgot.
Okay, that's okay. So coins, we know that we have two faces. One of them is head, and second one will be tails. So head, you can dice with 6 when you flip, and then the outcome will be like this: H, 1, 2, and then later on. And tails is the same, so your outcome will be writing like that. And the second one is the second result that you can recording. So here I believe you flip with 3 times, and then first time you got head, tails. Second time you got same thing, and then later on the same. And then after you got the outcome will be like this. The H is represent the heads and T is represent the tails. So here is something about coins probabilities. So William, do you wanna go?
Yeah, sure. Let me annotate just a second. Okay, so that's question 2, but it's the first question. 2 coins are tossed, find the probability that 2 heads are obtained. All right, so a coin has 2 sides, right? So we can say the tails is T and heads is H. Now, assuming the coin is fair, that means there are total of 2 different outcomes that can happen, heads or tails. And putting that on the bottom, that means a total, the probability that a single one of the outcomes will happen would be 1 over 2. So knowing that, we know that the probability to get 1 tail in 1 flip is half, 1 head in 1 flip is also half. Now, in 2 flips, 2 heads are obtained. That means in the first flip, you have the 1/2 probability of getting heads. And then in the second flip, you also have the 1/2 probability of getting heads. Now, the condition is that you get heads both times. So the first time, it's 1/2 probability of succeeding. And after applying that 1/2 probability of succeeding the first time, the second time also has a 1/2 probability of succeeding. Therefore, to find the probability of getting 2 heads in 2 coin tosses, that would be 1/2 multiplied by 1/2, which is 1 out of 4. Another way to explain this would be saying that there are 4 total ways that the 2 coin tosses could go. It could either be heads, heads, tails, tails, heads, tails, or tails, heads. Sorry if I went off the screen a bit. And the only one event that's successful is heads, heads, so it's 1 over 4.
Cool. Okay. So let's leave that for a second. And if you guys have any questions, just leave it. Yeah. And William, do you want to go over question 5 also?
All right. The next one would be a die is rolled and a coin is tossed. Find the probability that the die shows an odd number and the coin shows a head. Oh, okay. So we talked about, so this is 2 separate probabilities. Let's first look at that. The first one is the die shows an odd number, right? That's the first probability. And the second one is the coin shows a head. So since they're 2 separate probabilities, you calculate them separately first. Now, a die shows an odd number. Earlier, we learned that there are 3 odd numbers possible, and out of the total 6 numbers that you can roll on the die, so the probability of that is 1/2. And now we look at the second probability is the coin shows a head. And in question 2, we also saw that the coin has 2 sides, T and H, so the coin showing a head would be 1 over 2. All right, and the key thing to note here is that the word used to combine the probabilities is and. That means both must happen for it to succeed. Both must happen. That means the first probability of half must first happen, and the second probability of 1/2 must also happen. So that would be, sorry, that should be a dot. It should be 1/2 multiplied by 1/2, which would be equal to 1 over 4.
Yeah, and let's leave that for a second. And yeah, so probability is like more harder than the units that we learned before. So if you don't get it, like if you have any questions, just leave it for next class. And okay, some more harder cards probability problems. And Liz, do you want to introduce to us?
Sure. So card probability problems are a bit more confusing than coins and dice because they're just more events that could happen because there are 52 cards in all. And as you can see, 26 cards are red and 26 cards are black. So they're divided evenly. And there are 4 different shapes on the cards, as you can see. The first one is a heart, the second one is a diamond, third one is a club, and the fourth one is a spade. So these, you have to just recognize them because these problems come into tests and stuff very frequently. And once you get to know them, they'll be pretty easy. But for now, you just have to remember that there's 52 and 26 are red, 26 are black, and there are 4 categories of 13 each.
Yeah. So we'll give you like 1 minute to write those down. Okay. So questions about cards probabilities. Let's go with Alex.
All right, okay. I'll go over problem number 6, the first problem on the slide. The problem says a card is drawn at random from a deck of cards. Find the probability of getting 3 of diamond. Okay, so we know that there are 4 suites: diamond, spades, hearts, and clovers. So that limits our chance down to 1/4. Okay, that's the total number of suites that we can pick from. And since we can only pick a 3 of diamond, we can only use 1/4 of that probability. Now, the second part is whenever we look in a suite, there are 13 cards going from ace to king, and we can only pick a 3. So the only set of cards that can, I guess, satisfy this constraint is if we get a 3 in the diamond suite. So that gives us a 1/4 times a 1/13 chance, which gives us a 1 out of 52 chance. Now notice this: 1 out of 52 is also the chance that you get from putting any random card out of a deck. So just know that whenever they're asking for a specific card from a specific suite, know that it's always 1 out of 52.
Okay, so let's leave that answer for a second. Okay. Alex, do you want to go over with 7 also?
Yeah, sure. Okay, so problem number 7. A card is drawn at random from a deck of cards. Find the probability of getting a queen. Well, we know that there are 4 suites, and each suite has 1 type of card. So that gives us a total of 4 queens in the entire deck of 54 cards. So the P of getting a queen is equal to 4 queens over the total number of 52 cards. And that gives us 1/13. So the probability of getting a queen from randomly pulling a card from a deck of cards is just 1/13.
Okay. Yeah, and let's do some easy problems. So let's see. Ethan, do you want to do that?
Okay. So
Let's try.
I hope I'm right. Okay. So the first question is, what's the probability that the spinner will land on B? B is this big part of it. So let me annotate. Wait, how do you type? Okay. So we have 4 choice: likely, unlikely, certain, impossible. For this case, it's likely. It's likely, yeah, because it's a big part of the entire pie, so it have very great chance to get it. Yeah. And what's the second one? What's the probability that the spinner will land on A? Okay, so since number 1 is likely, so number 2 is unlikely because it's A, which is a small part of that pie. So it's possible, but it's not a very big chance. Which letter do you think the spinner will land on the least? Why? Okay, we'll put C. Yeah. C. C. Yeah, because there's no letter on the pie. So it won't never like spin to letter C. So because it's not on the pie. Pie. Yes. So it's impossible. Yes. Yeah.
Okay. So at that time for C, I think will be impossible, right? Because there is like no C on the what do you call it, like pie circle. So yeah. So here are more problems. So first one, what is the probability that the spinner will land on B? So first of all, we can like look at this. Maybe you divide with like same part. Let's see how many can we. Yeah, I think so. So will be 1, 2, 3. Will be 8 part. So it's asking you what is the probability that the spinner will land on B. So here, this part will be B. So since we have total 8 part, so B is just for 1 part. So it will be 1/8. And you guys can try number 2 on yourself, and we can check the answer together. Okay, so for second one, it asks you about what is the probability that the spinner will land on C. So as you see, C is yeah, is this part right here. So and since we know that total we have 8, and then C is like 2 part it has, so will be 2/8, and then you simplify that will be 1/4. Yeah. And Liz, do you want to go over 3?
Sure. So what letter do you think the spinner will land on the most? Well, as you can see, it's A because it like occupies half of the circle pie here. So it's like a big portion of this pie. So it will be A. And it's because A Q. Okay, yeah, you guys know I will not type. My spelling's like horrible. I don't want to mess it up. Yeah, so it's gonna be A because it occupies half of the pie. Okay.
Good. Okay. So I think I'll make some mistake on number 2 because I didn't see this part right here. So it will be like 3 over A since it have like I don't know, yeah. So final answer will be like 3 over 8 because you cannot simplify that. So 3 over 8. Let's moving on. Okay. Here is our word and n words in probabilities. So Liz, do you wanna go over that?
Yeah, sure. Okay, so or and n are two big concepts in probability. I think I talked about this like in the first problem that I did, and we multiplied two different fractions together, and William mentioned that the two outcomes doesn't affect one another. It's the first problem we did. So that one we use n because we multiplied the fractions, but here we'll deep more about it. So imagine that now you have a sphere 6-faced dice. What is the probability that you throw either a 1 or a 6? So keep that. Can I annotate? Hold on. Wait. Oh, okay. Well, here you will see it says an or over here. And then there is a 1/6 chance of throwing a 1. Also, there is a 1/6 chance of throwing a 6. Since both 1 and a 6 are acceptable in this question, we include both of them in our total possibility. So the probability P of throwing a 1 or a 6 will be 1/6 plus 1/6, which is 1/3. So see how here it says an or, then we use the addition because both are accepted, so we add up the probability. The second one is, what is the probability that you will throw twice resulting a 1 and a 6? So here we use the and. So this event has two steps. First, throw a 1. If not, this is not it. So then you can't keep going with it. Then second, you'll throw a 6 under the prism of a 1 before. So first, a 1's probability is 1/6. In other words, the event branches to two events. One is throw a 1 in the first try. We want this. And if the first throw isn't a 1, then we cannot calculate it. Then second, after you're throwing a 1, you throw the second time, which you want a 6, and the probability is also 1/6. So the probability of throwing a 1 and a 6 is 1/6 times 1/6, which is 1 over 36. Okay, I don't think that was very clear, but yeah. Okay. So you can kind of see that when you use an or, you add the fractions, and when you use an and, you multiply the fractions. So over here, you can see that the probability of A or B, like event A or event B, you will be the probability of A plus the probability of B, right? And then if you're doing the probability of event A and event B happening like both are happening, then you have to do the multiplication. And then down here, you can see the academic symbols. These are a bit confusing, but for now, I think you can just keep in mind that OR is plus and is multiply. So make sure you remember like this part.
Just write it down if you need. So, yeah. Okay.